Hey guys, welcome to the notes for writing Slope-Intercept form part 2. Our essential question is why are multiple representations important, and we're still in Unit 3B. So this is going to be our second time looking at Slope-Intercept form when we're writing the equations, and we've already seen it when we've graphed them. So let's go ahead and review what Slope-Intercept form is. Slope-Intercept form is y equals mx plus b. Now why is it called Slope-Intercept form? Well, because the equation gives us a slope and an intercept. The slope is represented by the m. The intercept is represented by the letter b, but not just any intercept, it is the y-intercept. And y-intercepts are typically written 0, number. The also important thing to note when we're talking about y-intercepts is that it's also known as our starting value. So these notes are going to build off of the notes previous to this, so I would recommend that you watch that video or catch up, or if you haven't already caught up on that day's notes, that you do, because I'm going to be moving pretty quickly in these. So number one, we're given the table, write an equation in slope-intercept form. Well, first we know that we need to write it in slope-intercept form, which is y equals mx plus b. Well, slope-intercept form needs a slope and a y-intercept. Well, I'm given a table here, and I'm not given a slope, and I'm not given a y-intercept either. I'm just given a bunch of points. I'm given 4 points. So the first thing I'm going to need to do is I'm going to find my slope. And to find my slope, I can pick any 2 points. So I'm going to go ahead and pick the first 2 points. So my first point would be 9, negative 8, and the second point would be 5, negative 6. We're going to go ahead and find our slope. Remember, the slope formula is m equals y2 minus y1 divided by x2 minus x1. So I'm going to go ahead and label my points. So x1, y1, x2, y2. So our m here is going to be negative 6 minus negative 8 divided by 5 minus positive 9. Okay, so anytime I plug in that second number, I always put parentheses around it. And this is going to simplify to positive 2 over negative 4, and that's going to simplify again, so you always want to check to make sure that it is in simplest form, and we can simplify this to negative 1/2, meaning our slope is negative 1/2. But did this question ask for you to just find the slope? No. We need to keep going. We need to go to find slope-intercept form. Because this does not give me a y-intercept, I got to keep going, and we're going to have to start in point-slope form. We can always use point-slope form as long as we have a point and a slope. And since I have a slope here that I just found, I can use any point on this table. Let's go ahead and use negative 3, negative 2. So I'm going to pick that as my point, negative 3, negative 2. And my slope is negative 1/2. Now remember, I want to plug this into slope-intercept form. And not slope-intercept form, point-slope form. So let me go ahead and write point-slope form down here so that we have it for reference. And we had some practice with this the first time we saw it. We're going to go ahead and plug in our information. So we have y, and we have x1, y1 here. Whoops. And then our y1 is going to be plus 2 because it's opposite signs, equals our slope of negative 1/2 times x, and then our x1 is going to be plus 3. Oops, I don't need anything out there. All right, so I've plugged in my point and I plugged in my slope. Now, did they ask for point-slope form? No, right? They asked for slope-intercept. We have to keep going. The important thing to note about slope-intercept is that the y is by itself, so we got to get the y by itself here. So first step I'm going to do is I'm going to distribute. That means that this left side is going to stay the same. So negative 1/2 times x is going to be negative 1/2 x. Then we have negative 1/2 times 3, which is going to give me negative 3 over 2. Okay. My next step here is I'm going to subtract 2 on both sides to try to get y by itself. And remember, you can only subtract by like terms. Y equals negative 1/2 x. And then negative 3 over 2 minus 2. We want that as a fraction. It's going to be negative 7 over 2. Now, our y-intercept here isn't super pretty, right? It's a fraction. But they're not asking us to graph it, so that's okay. And so if we wanted to, just for fun to identify, our slope here is negative 1/2, and our y-intercept is 0, negative 7 over 2. Okay, so this is kind of a review from the day before, and the only extra thing here is that our y-intercept is not a whole number, it is a fraction. All right, number 2, given f of 7 equals negative 2 and f of negative 3 equals 4, write an equation in slope-intercept form. Well, I'm given 2 things here, and I know their points are just points in disguise. So f of 7 equals negative 2. Remember, normally we see f of x. So the 7 is taking place of the x value. So that means that this is my x value. My point is 7, comma, negative 2. My other point that they're giving me is going to be negative 3, comma, 4. Okay, so I have 2 points. Let's go ahead and get slope-intercept form. I'm going to need the slope. And neither of these are the y-intercept, so I'm going to have to start in point slope also. So go ahead and find our slope here. M equals x1, y1, x2, y2. So we have 4 minus negative 2, negative 3 minus positive 7. So that's going to simplify to be 6 over negative 10. And that simplifies to positive 3 over negative 5. So our slope is negative 3 over 5. But this is not my answer, just part of my answer. We've done half the work. Now we got to do the other half, which is actually put it in slope-intercept form. Well, let's pick a point. Doesn't matter what point we choose. Let's pick the point negative 3, 4. And then we're going to use our slope of negative 3 over 5. So again, we need point slope form. And the reason why we have to do point slope form is because we're not already given the y-intercept. So that's why we have to keep going. Okay, so let's go ahead and write down point slope form here. Y minus y1 equals m times x minus x1. So we're going to start plugging in information, x1, y1. Y, and it doesn't matter what point you choose, by the way. I don't know if I stated that. It doesn't matter what you pick. Whoops, orange. Y minus 4 equals our slope, negative 3 over 5. X, and then our x1 is going to be plus 3 because it's opposite sides. Okay, once I get to this step, we want to get the y by itself, so let's distribute. So we have y minus 4 still here. Negative 3/5 times x is going to be negative 3/5 x. Negative 3/5 times 3 is going to be negative 9 over 5. Still trying to get y by itself, so we're going to add 4 to both sides. So y equals negative 3/5 x. And then negative 9 over 5 plus 4 is going to give me positive 11/5. And this is slope-intercept form. Y equals mx plus b. Okay, moving on. We have a word problem. Number 3, Tony is filling up his hot tub. The hot tub has 25 gallons in it currently. He can pump 4 gallons of water in the hot tub in a minute. Okay, so that means that he starts with 25 gallons already in the hot tub, and then whatever is filling up the hot tub is going 4 gallons of water every single minute. So each minute that goes by, you're getting 4 extra gallons. So because it's saying 4 gallons of water every minute, or in each minute, that's going to indicate to me, hey, this might be the slope. So my equation, remember, we need to look like y equals mx plus b. And then the other information that they give me is that it already has 25 in it currently. So let's go ahead and fill in the information we know. Well, y equals, what's our slope going to be here? 4x plus, or not really plus, because we don't ever know it's plus, right? It could be minus. So since they start with 25 gallons already, that's a positive 25 because we start with that. So that is going to be our equation. All right, next thing is, what is the slope and what does it represent? Okay, well, let's look at here and let's see what we got. Well, our slope here, remember, it's mx plus b, so your m represents the slope, so our slope here is going to be m. Our slope is 4. Well, what does it represent? It represents how much the hot tub is getting filled each minute. So the hot tub is getting filled four gallons per minute. Okay, the next thing we're asked to find is what is the y-intercept? What does it represent? Well, our y-intercept here is going to be 0, positive 25. Well, what does it represent? Remember, the y-intercept is your starting value, so it's going to indicate to me that it has something to do with that. Well, we know that he had 25 gallons in it already, so he started with 25 gallons already in the tub. Okay, moving on. If Tony's pool holds 105 gallons, what would be the reasonable domain and range for this situation? Okay, so domain and range. Lovely domain and range. We haven't talked about this in a while, but let's go ahead and write this down. So we have domain and range. So just to remind you that domain is associated with your x values and range is associated with their y values. So it's helpful to note what our x and y values are. Well, if you take a look at your slope, it's saying 4 gallons per minute. Okay, well, 4 gallons per minute, so that means we're talking about gallons and we're talking about minutes. Which one of those is going to be x? Well, you see how your slope is 4, it's 4 gallons per minute. Okay, so that means that the gallons is going to be our y and the minutes is going to be my x. And x is usually your time. But in the case that you can't tell, it's always going to be whatever it per something. So if it's per hour or per minute, that's your x. So because it's 4 gallons per minute, then your x is your minutes. So let's go ahead and write minutes here, which means my range is going to be my gallons. How many gallons are in the pool? Okay, so let's start with our domain. Domain is our minutes. What's the least amount of minutes I could fill my hot tub? 0. Now, the second question is, do I write this as inequalities or do I use a list of numbers? Well, I can have half of a minute and I can have half of a gallon. Because I can have parts of these things, this is going to be continuous, not discrete. If I have discrete, I'm going to be able to list my numbers. But if I have continuous, I need to use inequalities. So that means that I could fill it for 0 minutes, right? I don't have to fill it. And then I have x. And then is there a maximum amount of minutes I'm allowed to fill for? Yes, because your pool can only hold 105 gallons. If you keep filling your pool forever and ever, it's going to overflow and you're wasting water, right? So there is a maximum amount of minutes that we can actually fill the tub up. So let's go ahead and use our equation to help us. Well, the equation that we wrote above was y equals 4x plus 25, because we're going 4 gallons a minute and we already have 25 gallons in the pool. So let's use 105 gallons to help us because we need to figure out what's the most amount of minutes. Well, we know the most amount of gallons we can hold is 105. And I also know that gallons is my y value, right? Because our minutes is our x, our gallons is our y. So I want to plug in 105 for y because gallons is y, and then equals 4x plus 25. Well, I only have one variable left, and remember x is your minutes, and we're trying to figure out what's the most amount of minutes, so we need to solve for x. So the first thing we're going to do is we're going to subtract 25 on both sides. 105 minus 25 is 80, equals 4x. We still want to get x by itself, so we're going to divide both sides by 4. And we're dividing because 4 and x are being multiplied, so we have to do the opposite operation. So we have x equals 80 divided by 4, which is 20. But what does that mean? Well, we just put in the most amount of gallons that this pool can hold, and we solved for x, which is minutes. Which means if we fill this pool all the way to the top, the most it can be, then the maximum amount of minutes that you can actually fill it for is 20 minutes. Okay. Now let's talk about our range. Well, our range is our gallons, right? Well, what's the least amount of gallons? Now, I know you want to say 0, but your pool started with already 25 gallons. Because you already started with 25, that's the least amount because you already had 25 gallons in that pool, okay? And then you have your y, and then what's the most amount of gallons you can put in the pool? 105. So we didn't have to solve this one because they told us what our maximum amount of gallons was, okay? So we did have to solve for the minutes because we needed to figure out how long that would take. But it would take 20 minutes to fill it to 105 gallons, and then our range would be from 25 gallons to 105 gallons. All right. Moving on to number 4, Gina works out at the gym to train for a marathon. So far, she has worked out for 8 hours and plans to continue working out 5 hours per week. So she's already worked out for 8 hours, and then every single week she's going to work out for 5 hours no matter what, okay? So So now we're going to write an equation in slope-intercept form. Well, I know that she has already worked out for 8 hours. So she has worked out for 8 hours. We know that she's already done this. Okay, so she has that. She started with that. And then she's working out 5 hours per week. Well, per indicates to me that this is probably the slope. Now, I know it's y equals mx plus b. So let's go ahead and fill in our information. Y equals, well, our slope here would be 5 because she's going 5 hours per week. And then our y-intercept would be positive 8 because she's already started with 8 hours and then she's going 5 hours every week. Okay, well, what do the x values represent? So we have two values that they're talking about here. And you want to look at your slope if you're confused on what your values are. You have hours per week. So we need to figure out which one's x and which one's y. And this one's a little tricky because hours and week are both time, right? They're both time. So it's like, well, which one's x, which one's y? I don't know. So again, you want to look at your slope. It's 5 hours per week. That means that my x is my weeks. It's 5 hours per week. So x is going to be the week, or weeks. So all of your x values mean weeks. So if I put in, if x equals 1, that means I'm talking about 1 week. Then what do the y values represent? Well, the y values represent your hours, because depending on how many weeks you've gone, that's how many hours you're going to be working out for. So if you work for 5 weeks, or you go through 5 weeks, and you're going to work out a specific amount of hours. Your hours depends on how many weeks. Remember, y's are dependent. Okay, so part B, what is the slope and what does it mean? Well, our slope here is 5. It means that she works out 5 hours each week. She's working out at a rate of 5 hours each week. Our y-intercept is 0, 8. Well, what does that represent? It means that she has already, or she started off with already 8 hours worked out, or she already worked out for 8 hours. Okay? Part D, find the number of hours she worked after 12 weeks. So this is when we're going to want to use our equation. Well, the equation we wrote above was y equals 5x plus 8. Now, it says that we want to find out for 12 weeks. So was 12 weeks our x or our y? Let's figure that out. Well, at the very top, we decided that our x values represent our weeks. So that should probably be in pink then, since it's weeks, right? So these are weeks. These are our x values. X value. So you're going to plug in 12 for x because it's 5 hours per week. So you're going to plug in that 12 for the x value. So y equals 5 times 12 plus 8. And the reason why you don't plug it in for y is because, remember, y is your hours, and we're plugging it in for 12 weeks. So y equals 5 times 12 is 60. So then we have y equals 68. Well, what does this mean? It means that after 12 weeks, she has worked out for 68 hours. Okay, last one is what is a reasonable domain and range for this situation? So let's go ahead and write our domain and range. Domain and range. So we know, again, domain is our x values and range is our y values. And we want to look at what our x values were. So our x values we said were weeks. So let's go ahead and write our weeks there. And I think I had it in red, so let's go ahead and do weeks in, or I think it was pink actually. And then we did our hours in red. So range is our hours. So hours depends on how many weeks. And again, we got that up from the very beginning. Okay, so domain, this is going to be a continuous problem. So we're going to need inequalities again, and I'll tell you why. Because you can have half of a week and you can have half of an hour. So this is going to be continuous. So what's the least amount of weeks she could work out for? Well, 0, because she doesn't have to work out any. She's already worked out 8 hours, so it doesn't really matter. So she could work out for 0 weeks, right? Is there a maximum amount of weeks that she could work out? No. She can keep working out forever. So there is no limit over here, so you leave it blank. Okay, so then you're just done with that. For the next part of our hours, what's the least amount of hours that she could have worked out for? Well, she started with 8, so that's the minimum, right? You don't want to say 0 because she did start off with already 8 hours. And then this is going to be our y values. And then is there a maximum amount of hours she's allowed to work out? No, right? Because the more weeks go on, she's going to work out even more. So it's just going to keep getting bigger and bigger, and her hours will keep increasing. So that is it for these notes. A little bit was added on compared to the day before. We're talking about domain and range a little bit and just applying that to our linear equations. If you have any questions, please feel free to come in for tutorials.